Hey everyone, welcome back to another video. I'm going to be doing some Newton's law questions today. If you'd like to read the question, please pause the video and go through it. I'm going to be going through the answers. So question 1.2 here says, draw a labeled free body diagram indicating all the forces acting on the 5 kilogram block. So the 5 kilogram block is going to have tension pulling it up, so T2. It's going to have gravity pulling it down, and it's also going to have T1 as well. Question 1.3, calculate the magnitude of the tension T1 in string P. Now, to do this, I need to draw a free body diagram for the 20 kilogram block. So for the 20 kilogram block, I'm going to have force of gravity pulling it down, and I'm going to have T1 pulling it up. I'm going to choose up as positive, and I'm going to apply F net equal MA to both. So for this one, I'm going to have F net equal MA, T2 minus T1 minus FG is equal to MA. And here I'm going to have T1 minus FG equals MA. Now T2, we've been given as 250 minus T1 minus FG is going to be 5 times 9,8, and that's going to equal the mass times the acceleration. Then for the 20 kilogram block, T1 minus 20 times 9,8 is going to equal 20 times A. Now I can divide everything by 5, divide everything by 5, here divide everything by 20, divide by 20, and that's because I want the tension. So I'm going to say that the acceleration is equal to the acceleration 250 minus T1 minus 5 into 9,8 divided by 5 is going to equal T1 minus 20 into 9,8 all over 20. You can then solve for T. You can use your calculator or solve it. So T1 is going to equal 200 newtons. Now taking a look at question 1.4. Question 1.4 says, when the 250 Newton force is replaced by a sharp pull, which rope will break? The answer here is going to be Q. It's going to be Q because Q is experiencing a greater force right now. And since the new force is going to be applied on Q, P is not going to have any time to react since it's a jerk. So Q is then going to break. Now I'm going to look at question 2. If you want to go through the question, please pause the video. Question 2.2 says, draw a label free body diagram showing all the forces acting on the 1 kilogram block. So on the 1 kilogram block, there's going to be the normal force acting up the slope. There's going to be force applied. There's going to be the force of gravity. There's also going to be friction, and there's going to be tension. So there's going to be 5 forces essentially. Question 2.3.1 says, calculate the kinetic friction force between the 1 kilogram block and the surface. So kinetic friction, Fk, is going to equal mu k times Fn. Now mu k we've been given as 0,29, and Fn is going to equal the perpendicular force of the weight, and that's going to be mg cos theta. So 1 times 9,8 times cos of 30 degrees, the angle of the slope. And that's going to give us an answer of 2,46 newtons. Now question 2.3.2 says, calculate the tension in the string connecting the two blocks. So once again, we'll apply F net equal MA to both blocks. I'm going to draw a free body diagram for the 4 kilogram block. There's going to be tension, there's going to be normal, gravity or weight, and friction. Now let's choose up the slope as positive. So for the 4 kilogram, I'm going to have F net equal MA, T minus F minus, and not forgetting the parallel component of the weight. So W parallel equals MA. Now the tension is what we don't know. The friction we've been given for the 4 kilogram block is 10 minus mg sine theta. So 4 times 9,8 sine of 30 degrees. And that's going to equal 4a. Now for the other block, for the 1 kilogram block, we have the free body diagram. And so we can say F net equals MA, the force applied, which is 40, minus the tension, which we don't know, minus the friction, so 2,46, and minus, there's also W parallel down here. So W parallel is going to be mg, so 1 times 9,8, and then sine 30, and that's going to equal 1a. So mass is 1 and then 1a, so that's a. Now we can divide this whole side by 4, divide that whole side by 4. We don't need to divide by 1 here since it's still the acceleration. So let's call that equation 1, and we'll call this equation 2. We can then equate and then solve. So we can say that 40 minus t minus 2,46 minus 9,8 sine of 30 is going to equal, so 1 equals 2, and it's going to equal t minus 10 minus 4 into 9,8 times sine of 30. So that's equation 1, and that's equation 2. And we can then solve for t. T is equal to 32,04 newtons. Now let's take a look at question number 3. Again, if you want to attempt the question, please pause the video, and I'm just simply going to go through the questions. Question 3.1, draw a labeled free body diagram showing all the forces acting on the 5 kilogram block. So on the 5 kilogram block, we're going to have gravity, you're going to have the normal force, we are going to have tension, we're going to have force applied, and we are going to have friction as well. Question 3.2.1, calculate the vertical component of the 60 Newton force. So vertical is Fy, that's equal to F sine theta. So 60 sine of 10, which is equal to 10.42 newtons. Question 3.2.2, calculate the horizontal component. Fx is equal to F cos theta. So 60 times cos of 10, which is equal to 59.09 newtons. Question 3.4, calculate the magnitude of the normal force acting on the 5 kilogram block. So remember, there is going to be, because there is a vertical component here that's pulling upward, we need to account for that. So the Fy plus the normal force is going to equal Fg, because we have those two forces that's going up and we have Fg that's going down. So the normal force is going to equal Fg minus Fy. So Fg is mass times gravity, so 5 times 9,8 minus Fy was 10.42. We can then solve for the normal force, which is 38.58 newtons. And lastly, question 3.5, calculate the tension connecting the two blocks. Once again, we need to do simultaneous equations. I'm going to choose left as positive. So I'm going to apply F net equal MA for the 5 kilogram block. So for 5 kg, F net equals MA. You have Fx minus friction minus tension equals MA. Fx is 59.09 minus the friction, which we can calculate. The friction is equal to mu k times Fn, and then minus the tension is equal to 5a. So 59.09 minus mu k, so the kinetic or the coefficient they've given us is 0.5, so 0.5 times the normal, which is 38.58, minus the tension equals 5a. Then we'll apply for the 2 kilogram block. Remember, the 2 kilogram block simply has two forces acting on it, one being tension and one being the weight. And if you're choosing up as positive here, for the 2 kilogram block, we're going to have F net equal MA. Tension minus weight is equal to MA. So tension minus the weight is going to be 2 times 9,8. That's equal to 2A. Now you can divide this by 2, divide that by 2, divide this entire thing by 5, and that entire thing by 5. Now we can equate them. So 59.09 minus 0.5 into 38.58 minus T all over 5 is equal to T minus 2 into 9,8 all over 2. And the only thing we don't know is T. We can then solve for T, and T is thus equal to 25.37 newtons. Now let's take a look at question 4. We've been given the scenario. I urge you to please pause the video now, read through it, attempt it, and let's go to the answers. So question 4.1.2, calculate the tension in the string. So they tell us that it's stationary. So if I draw a free body diagram for the 2.5 kilogram block, you have the weight, you have the tension. Because it's stationary, the tension is equal to the weight. So the tension is equal to 2.5 times 9,8, which is equal to 24.5 newtons. Now taking a look at the next part, the coefficient of static friction mu s between the unknown mass m and the surface of the table is 0.2. Calculate the minimum value of m. Calculate the minimum value of m that will prevent the blocks from moving. Okay, so question 4.1.3. What we need to do here is draw a free body diagram for m. So m is going to have its force of gravity, it's going to have its normal, it's going to have its friction that's going to prevent it from moving to the right. So friction will act left, and there's going to be tension. So we want it to stay stationary. So that means we want the tension to equal to the friction, right? And friction is equal to mu s times Fn. So we worked out the tension to 24.5 is equal to mu s, which is 0.2. And the normal force is going to equal the force of gravity, which is going to be m times 9,8. And now we can solve for m. So m is going to equal 12.5 kilograms. So for 5 marks, not too difficult. The next part, 4.1.4, the block of unknown mass m is now replaced with a block of mass 5 kilograms. The 2.5 kilogram block now accelerates downward. The coefficient of kinetic friction between the 5 kilogram block and the surface of the table is 0.15. Now here, I'm going to draw free body diagrams again. So we have tension, we have friction, we have the normal, we have gravity or weight, and this time we have acceleration that way. And for the other block, we have tension, we have the weight, and we have acceleration downward. So they want us to calculate the acceleration, calculate the magnitude of the acceleration of the 5 kilogram block. So the acceleration of the 5 kilogram block is going to be the same as the acceleration for the block M, or the 2.5 kilogram block, because it's all one system, it's all connected with the same rope. So we can apply F net equal MA to each one and then solve simultaneously like we've been doing before. So here I'm going to say T minus F is equal to MA, and here it's going to be W minus T is equal to MA. Now let's substitute whatever we can. Tension we're not sure of because it's a new block, so it's going to be new tension. The friction is going to be 0.15, which is the new coefficient, and then into 5 times 9,8. And that's going to equal 5A. Now for the 2 kilogram block, you're going to have 2.5 times 9,8 minus the tension is going to equal 2.5A. Now we want acceleration, so we'll simplify as far as we can. So we're going to get t minus 7,35 is equal to 5a. And here we're going to have 24.5 minus t is equal to 2.5a. Now let's solve in terms of t. So we're going to have minus, let's do this. Let's say that t is equal to 5a plus 7.35. And here we can say that 24.5 minus 2.5a is equal to t. We can now solve for t since t is the same. We're going to equate this. We can equate this and we can equate that. We can say that 5a plus 7.35 is equal to 24.5 minus 2.5a. We can solve for a is equal to 2.29 meters per second squared. They just asked for the magnitude, and so the direction is not needed. Question 4.2, a small hypothetical planet X has a mass of that, and they want us to calculate the gravitational force, the weight that is exerted on a 90 kilogram block. So first we must calculate the force of gravity, or what is the acceleration due to gravity. So that's g is equal to gm over r squared. G is 6.67 times 10 to the power minus 11, multiplied by the mass of the planet, which is 6.5 times 10 to the 20, divided by the radius of the planet in meters is 550 times 10 to the power of 3 squared. And that gives us 0.14 meters per second squared as the acceleration. So to calculate the weight is going to equal mass times gravity. So 90 times 0.14, which is equal to 12.9 newtons.